First of all, can anyone tell me anything about the graph, about the shape?
These students are exploring the relationship between turning points and equations of lines. Prior to this lesson, they had been using activities to deepen their understanding of factorising and completing the square for different quadratic expressions. In this lesson, the teacher is using a graphing application to draw on this prior learning to help make connections between equations of lines and their turning points. She begins by looking at the line y equals x squared.
I'm interested in what the graph of x squared plus 1 would look like.
Would it be upwards inside them?
Oh, plus 1 is on the y-axis, so it's up. Like that.
A lot of people have drawn this graph here, which is correct. We could start off with something quite basic like x squared and kind of pick out the properties of the graph and really get to grips with some of the key vocabulary that the students might use as well. What is the y-intercept of this graph, Sophie? Cross the y-axis at 0, 0. The next graph that I was interested in was x squared plus 1. And what is the y-intercept of this graph, Claudia? 1 as well. The fact that I could move the graphs around quite easily and ask lots of different questions to the students was really powerful. I could also get a lot of feedback from the students as well because of the rapid pace. I want you to draw on your piece of paper y equals x squared minus 4. The students responded well to that and thought that was a really good introduction to the task, and it linked well with the work that we've been doing so far on completing the square. A lot of people have correctly got this graph here, and I was also interested of looking at the 2 points where it crosses the x-axis. Can anyone tell me how I would find those 2 points, Claudia? Factorise it, good. Okay, so what does this factorise to?
X minus 2x.
Good, x minus 2x plus 2. For this graph, x squared, we looked at this point here. Can anyone tell me what we call this point?
Minimum point.
The minimum point, good. So the coordinate of the minimum point for x squared is 0, 0. What's the coordinate of the minimum point for this graph here?
0 minus 2.
0 minus 2. Okay, what's the minimum point here for this graph?
Having actually been able to see the coordinate on the graph and then having next to it the equation, it brings into focus the numbers that are used, and it's quite obvious then when they're put together where you get the numbers that correlate to the graphs.
As I move the graph vertically up and down, we can see the translation and we can see the minimum point. Okay, let's have a look at translating it horizontally. So what I'm interested in is the equation of this purple graph here.
Because it's a parabola, so the x has got to be squared.
What I've seen from a lot of people is the correct answer, x minus 4 all squared. Does anyone tell me how they knew that was the equation?
Is it because when it's in the bracket, it's lying, so you have to do the opposite of what it is?
That's the little phrase that we used when we were looking at this topic. Excellent. So it's moved right 4 units, and we say x minus 4 all squared. If I was to factorise this, what would be the solution or solutions for this?
X equals 4.
X equals 4, good. What happens if I go to the left? Rach?
Is it y equals x plus 5 squared?
X plus 5 all squared, excellent. Let's try and combine the two of these together.
Because we started off at 0 and then we moved it along to the right, which made the correlation negative. And then we moved it to the left, and then we moved it up a little bit. So we kind of took it in stages to see where the different parts came from.
So we started with y equals x squared, but then we changed how the plus whatever on the end of that, changed it vertically. Then we went back to y equals x squared and we changed it horizontally.
You sort of get a better idea of how the original equation affects the entire graph, whether it moves left, whether it moves right, up or down, or it becomes negative or positive.
Owen, what have you got, please?
I got x minus 4 squared plus 2.
X minus 4 all squared plus 2, excellent. How does that link to what the minimum point is, Owen, of the actual graph?
It's 4, 2.
4, 2. How do these two relate, Alex?
The y coordinate is the number outside the bracket, whereas the x coordinate is the opposite sign of the one inside the bracket, the number inside.
Excellent. I've got the graph y equals x plus 3 all squared minus 1. What would the minimum point of this parabola be?
-3, -1.
-3, -1, perfect. Okay, last one, can you have a go of drawing this out and writing the minimum point on your board, please?
That'll be the minimum point. And it crosses, yeah.
Okay.
Because that has the opposite effect, and it's not be -2 and then -2 plus 3.
Yeah.
So I think from there we'd be looking to do an activity such as this where they're looking to link the minimum point of the graph to the completed the square form, the graph itself, and also an expanded version of the completed the square form. So for example, I might pick out this one here and we could look at the minimum point of the graph as -2, -1, which would link to this one here. And then we might match that up with the completed the square form. If that's not on there, then I'm looking to use one of these green strips. So I'm looking for x plus 2 all squared -1, and then finally the fourth one to match up would be the expanded version of the completed the square form. And again, there are some very similar but not quite the same.
So they can't just rely on spotting number patterns, they've actually got to think about it.
Yeah, so it's practicing lots of different skills, practicing expanding the brackets, practicing the link between the completed the square form and the parabola.